Hello scientists, it's so good to see you again. Welcome back to Room 9, our region's largest classroom. Remember, my name is Mrs. Stobbs and I teach kindergarten in the Maplewood-Richmond Heights School District right here in St. Louis. And today we're going to do another science lesson for kindergartners and for preschoolers, but of course anyone is welcome to join us. So if you're ready to have some fun, let's get started. Now I want you to think back to last week, if you watched last week, and I want you to think about what we learned. We learned about some special science tools that all scientists have right on their body. They don't have to look for them, they already have them on their body. And these tools help the scientists observe the world around them and take that information in and then learn about the world around them. Do you remember what these special tools are called? They're called our 5 senses. Do you remember what our 5 senses are? There are 5 of them. Last week we learned a special song to help us remember. See if you can join me. Maybe you remember it. It goes like this. My 5 senses, help me learn, see, hear, smell, and taste and touch. See, hear, smell, and taste and touch. They talk to my brain, Great job! You remember. Our 5 senses are seeing, hearing, smelling, tasting, and touching. And I hope that last week you got to do some of the experiments that we did on our video. Those experiments were really fun and they got to test out all of your 5 senses. And all you needed to do them was maybe a grown-up and just a few items from around your house. So if you want to watch that video, go back and watch it from last week and you can do some of those fun science experiments to help you learn about your 5 senses. But we also said that our 5 senses aren't just fun, they're very important. They're important to us because they help make sense of our world and we learn about the world, but they're important to scientists too. Scientists learn about their world through observations by looking at things and by listening to things, so their sense of sight and their sense of hearing. And a lot of scientists also use their sense of touch and they compare things. Maybe they notice how things feel or they notice if something gets hot or cold. Scientists use those 3 senses a whole lot. Now those last 2, your sense of taste and your sense of smell, a lot of scientists don't use those because it can be dangerous to smell things that you don't know what they are or to taste things that you don't really know what they are. Or if you do know what they are and you know that they're just dangerous. But there are some special scientists who have a special job where that's the main sense that they use. So there are some scientists that work on creating special flavors for foods, like maybe for candy or for popsicles. And there are some scientists who use their sense of smell and they create new perfumes or maybe new candles. So there are scientists that use all 5 of their senses. Awesome. Now today we're going to learn about some other tools that help the scientists make their senses their super senses. Da 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 da! Super senses unite! And these tools just help scientists use their senses in an even better way, because sometimes you can't see, or there are things that we can't see just with our eyes. There are things that we can't hear just with our ears. There are things that maybe we need to use to help us feel things even more. Or maybe we don't want to touch something, so we need to figure out how to use them in a different way. So these tools help our senses become super senses. So are you ready to learn about some special tools that help scientists make their senses become their super senses? All right, let's get started. The first tools that we're going to learn about help scientists turn their sense of sight into super sight. So like I said, there are things around us that we can't see. And so we need special tools to help us get a closer look at the things that we can't see. So can you think of a special scientific tool that helps scientists use their eyes in an even better way? I can think of a few. And I have a few right here. Whoa! Do you know what this is? This is called a hand lens, or sometimes we might call it a magnifying glass. And this helps us see things that we can see. This doesn't really help us see things that we can't see just with our eyes, but it helps us get a closer look. So if you wanted to get a closer look at that letter C, right now look at how small it looks. But whenever I put the magnifying glass there, does it get bigger? It does. Or my eyeball. Here it's pretty small, but there it gets really big. Or even just my face. It's a normal size face, but whoa! So it's fun to play with these, but scientists use them in a real way. So I have some rocks here. I'll just hold up one rock at a time, and I can see this rock. I can notice some special details on it, but if I use the hand lens, I can get an even better idea of what it looks like. Oh, I can see a spot that I didn't see before, and the sparkles look extra sparkly. Can you see this rock? Get a little bit closer. How does it change? How does the magnifying glass make it change? Is it getting bigger or smaller? What if I go back a little bit? Here it is, bigger or smaller? What do you think? I could also use this to maybe look and compare two different rocks. Ooh, this gray rock right here, it looks even sparklier with the magnifying glass. And I can notice, I noticed some extra rough edges on both of the rocks that I didn't notice before. So you can use a hand lens or a magnifying glass to help you see things a little bit better, okay? So that is one super senses, super sight tool that scientists use, but I have another one. Do you know what this is called? This is called a microscope, and a microscope is even cooler than the hand lens because this can help us see things that we can't even see just with our eyes. The magnifying glass helps us see things a little bit better, but usually you can only look at things that you can really already see. But the microscope makes our sense of sight so good that we can even see things like germs that we can't see on our hands. We have germs on our hands and around us all the time, and that's why we need to wash our hands before we eat, or why we wash our hands after we go to the bathroom. But we can't see them. Our hands usually don't look dirty. Even if our hands look clean, we still probably need to wash them. This microscope can help us see those things that we can't just see with our eyes. So a microscope has two spots for your eyes, so I can put my eyes down like that, but it also has a spot down here for you to put something small. So this thing that I have, it has some different pollen on it, and if you look close, you might be able to see some little dots, some little specks, but you can't get a close look. I'm looking at it and I just see things that just kind of look like little polka dots. But if I put it on here, if I put it on my microscope, I'm going to put my eyes in the eye holes. I have to make sure I can move it down. And right now it's kind of blurry. So there's a dial here that I can turn. Ooh! And now I can see those pollen specks really well, and they look really, really cool. They look different than what they looked like whenever I just looked at them with my eyes. Now it's hard for me to show you through this with the camera, so I have some pictures of some different things that cameras have taken, and some microscopes have taken pictures of, so you can see some teeny tiny things that you wouldn't get to see with your eyes. So this first one right here, these are actually some germs. They're little virus cells, and that's what they look like. That's what viruses look like, or germs look like. We can't see them just with our eyes, but if you have a microscope, it can help you see that. It's pretty crazy, huh? Here's another one. You might be able to tell what this is. It's a wing of an insect. Isn't that pretty cool? Insects are usually so tiny, so it's hard to get a close-up look of their wings, but a microscope can help us get a better idea of what they look like. And then the last one, these are red blood cells. So whenever you look at blood, like if you get a cut and you start to bleed a little bit, it just looks like some little red drops. But this is actually what blood looks like. The red blood cells look like under a microscope. Do you see how it's they're separate? It's not just it's not like a whole bunch of liquid. It's not like your blood is dripping. They're little dots almost. Isn't that pretty cool? So microscopes and magnifying glasses help us see things that are small, and they make small things big. But there are some other tools that help us see things that are far away, that are too far away for us to see with just our eyes. But if we use these special tools, we can see things a little bit better. Do you know what they are? Let's check them out.
Wow, I can see a bird in that tree way over there. Oh, I can see so many details on its body. Look at its feathers. Wow. Friends, do you know what these are called? These are called binoculars. And binoculars help us see things that are really far away. And it makes those things that are really far away look really close so we can observe them very carefully. So if I look right now with just my eyes, I can see the bird, but it's just kind of a shadow. It's really far away, so I can't see many details, but I can see details using the binoculars. And binoculars turn our sense of sight into super sight. And scientists, especially biologists, love to use binoculars to look at animals from far away. But what if we wanted to look at something even farther away than that bird in that tree? What if we wanted to look at something in space? Could we use binoculars? No, we couldn't. We could see them, we could use it a little bit, but it wouldn't help us very much. Do you know what the name of the tool is that helps us see things in space, like stars and like the moon and even other planets? Do you know what it's called? I have one right over here. Let's check it out. Do you know what this is called? This is called a telescope. And a telescope works like binoculars, but it helps us see things that are in space. We can see stars, we can see the moon, we can even see other planets. And so scientists use this to learn about space. Isn't that great? It turns our sense of sight not only into super sight, but to super duper sight. And it works kind of the same way as this and even the microscope, because there's a special spot right here that I can look into. So I'm going to take a look. And right now I just see, I think, clouds in the sky because it's a little bit too light out here for me to see stars or the moon. But I think I might come out here a little bit later and check out some stars and the moon and use this to help turn my sense of sight into super duper sight and learn even more about space.
Scientists also use tools to help them turn their sense of touch into super touch. So we know that we can touch different things and we can feel if something is hot or cold or smooth or rough or wet or dry. We can feel those. But scientists use some tools to help them get an even better understanding of those senses. Have you ever seen this before? I bet you've seen this a lot, especially right now. This is a thermometer. And what does a thermometer do? A thermometer takes your temperature. We put it under our tongue or maybe under your armpit, and it takes your temperature, and it tells how hot or cold something is. Scientists use thermometers all the time, and especially if they're working in a lab, or maybe if they're even working with animals, they might take an animal's temperature. So scientists use thermometers to help them figure out if something is hot or cold. And we're going to do that today. So I have some different thermometers. This is a different type of thermometer than this one. This one is just to check my temperature, but these are special scientific thermometers. And we're going to test out some water. I have 2 cups of water here, and one is a hot cup of water and one is a cold cup of water. Can you tell which one is which just by looking? You really can't. Now I can tell if I touch this one or I touch this one. I can tell what the temperature is, but you can't reach in my screen and touch it yourself. So we're going to use a thermometer to tell us what the temperature is. And you can see that this thermometer has a red line, and whenever it gets hotter, that red line is going to go up, 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 and whenever it's colder, it's going to go down, 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 down. So right now, the thermometer is at about 20 between 20 and 30 degrees Celsius. So about probably 26 degrees. But watch what happens when I put it in this cup of water. Let's see if I can get the line to show. What do you notice? Is it going up or down? It was at 26. Now it looks like it's at 13. 13 degrees Celsius. Or we could look at this other number on the other side and see that it's about maybe 53 degrees Fahrenheit. Okay, but now let's try the other cup. So again, right now, let me see if I can find it. The line is at about 23 degrees Celsius or about 73 degrees Fahrenheit. But watch what happens when I put in this cup of water. Is it going up or down? I see it going up. Now it's close to about 43 degrees Celsius or about 105 degrees Fahrenheit. Oh my goodness, so that one went up and this one went down. This one is still about 13 degrees Celsius or 54 degrees Fahrenheit. I'm going to pull them both out so we can compare the two thermometers. And I'll see if I can get both of them in the right type of light. It's a little tricky since these are so shiny, but I'll see if I can get both of them. All right, so there's that one. Oops, I don't know if I can get both of them. But this one over here, you can see both of the reds a little bit. This one over here was a lot taller. This one right here. The red, there was a lot more red on it. So that means that this cup of water over here, this cup of water is much warmer than this cup of water. This cup of water was the cold cup of water where it was only about 13 degrees Celsius, where this one was about 45 degrees. Let's see if I can get it again, about 40, maybe 44 degrees Celsius. So we can now know what the temperature actually is, and we don't just have to say cold or hot. We can write down, if I had my notebook with me right now, I would write down that this cup of water was only about 13 degrees Celsius and this one was about 44 degrees Celsius. And we don't just have to say hot or cold, we can actually give a number, and scientists love to work with numbers. So these thermometers are another super senses tool that help us make our sense of touch the super touch. There are also some special science tools that help scientists measure things. Do you know what that means, to measure something? It just means that we want to figure out how big, how small, how long, how short, how heavy, how light something is. And there are lots of different types of tools that will help us measure. So we're going to start with something to see how long something is. I want to know how long this pencil is. What would I use to help me figure out how long this pencil is? Have you ever seen a ruler before? A ruler can tell us how long or short something is. But whenever we measure with a ruler, we have to be very careful to line things up just right. In this ruler, we can see how long it is in inches and also in centimeters. Scientists usually use centimeters though, so we're going to act like scientists today. So I'm going to measure this pencil. So the way I'm going to measure this pencil, I am going to make sure that the end of my ruler actually isn't where the measurement begins. The line is right here. So I'm going to make sure I line up that eraser right where it says centimeter, S or cm, and then I'm going to look all the way up here. And the pencil is 19 centimeters long. So I'm going to record that in my notebook. I'm going to draw a picture of a pencil and maybe even write a P for pencil and write 19 centimeters long. And I recorded my data. Now, what if I wanted to measure something longer than how long this ruler is? Like this easel. I could try to line it up and put my finger there and then move it down, but that gets really tricky. So we have longer rulers, and this one is called a tape measure. And a tape measure can keep on coming and coming and coming and coming and coming and coming and coming, and it even can go farther than my arms. And this can measure taller things or longer things. So I'm going to put the bottom of this tape measure at the bottom of the leg of the easel, and I'm going to go up, 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 up. And the easel's leg is about, this one is 43 inches, and I just need to look at inches for this one. So 43 inches. So I'm going to draw, again, I'm going to draw my easel. And it might not be the best easel, but that's okay. And then I'm going to write 43, and then I'm going to write inches. Inches. That way I know what I measured, because I measured in 2 different types of measurement, which is something that scientists try not to do. But this tool only had inches on it. So that's 2 ways that you can measure things. Now, what if I wanted to measure something that wasn't straight? Before we measured a pencil and the leg of the easel, and they were both straight. But my dog Oliver, he isn't all straight lines. He has some curvy lines too. So what if I wanted to make a new shirt for Oliver, and I wanted to know how big around his chest is, or how big around his belly is? Could I use a ruler for that? Oliver's sniffing it out. He says, I don't think that's gonna fit around my body. And Oliver, you're right. We can see how tall you are. Oliver, can you sit up? We can see how long he is from his nose to his tail, but I can't measure around his body with this ruler. And I can't really use this either. This can bend a little bit. Oh, Oliver's very interested in all these tools. It bends a little bit, but it still has some corners. So I'm going to use another type of ruler, another type of tape measure. And I'm going to wrap it around Oliver's little body. Oh, Oliver, can you stay standing up? He might lay down. He's pretty sleepy right now. And I'm going to see where we are here. Here we go. I had to find the right side to look at. And I'm going to wrap it around his little body. He says, wait a minute, that tickles. That tickles, Mrs. Stobbs. And then so I've wrapped it all around his body, and I pinched it together where it meets. And now I'm going to unwrap it, and kind of in the middle of his body, it's 20 inches. And Oliver wants to say hi to the camera. 20 inches is how big around his chest is, or his belly. So I'm going to draw a picture of that too. So I'm going to draw his little body, his legs, his back legs. He has kind of a curly tail like that, his ears. And I'm going to write around here and then say, oh, what was it, 26 inches? I think it was 26. You know what? I'm going to measure again, because sometimes scientists need to measure again. And I forgot already. Silly Mrs. Stobbs. Oh, and Oliver's going to cooperate. Thank you, Oliver. Let's look. Just 20. So I'm glad I double checked, because I forgot my data. But Oliver, thank you for letting me help you. So 20 inches. And again, this ruler didn't have centimeters on it, so I went with inches. So here's the data that I've taken to measure how big or how long things are. And thank you, Oliver, for letting us measure you. He says, you're welcome. Thank you, little scientists. All right, so now that we have measured the length of some different things to see how long or short they are, we're going to measure another attribute, and that attribute is weight. We're going to see how much something weighs. So I have 2 rocks here, and I can use my sense of touch, and I can tell between these 2 rocks, this rock is a lot lighter than this rock. But I want to use a special scientific tool to help me see if my hypothesis is correct. And that special tool is a balance. And a balance is kind of like a seesaw or a teeter-totter on the playground. And if you put 2 things in it, and whatever's heavier goes down to the ground, and whatever's lighter goes up in the air. So we're going to use this rock, we're going to put both of these rocks on the balance, and we're going to see what happens. So I'll put my lighter rock in first, And whenever it compares with nothing, it's obviously heavier. But let's see now, whenever I put my heavier rock in, what happens. Whoa! It jumped up in the air. This rock is so much heavier than that rock is that it pushed that rock even up into the air. So my hypothesis was correct. Now, I'm going to check something else because I have another rock that's very similar to this rock. They're the same type of rock and they're the same size. What do you think will happen when I put these rocks in? I'm going to put them in at the same time. What happened? Did one side go up and one side go down? No, it's straight across. It's balanced. What does that tell me? That tells me that these two rocks weigh about the same. One of them isn't a lot heavier or a lot lighter than the other one. They weigh the same. That's pretty cool. Now, what if I wanted to know exactly how much these rocks weighed? Would the balance tell me that? No. So what do I need? I need a scale. And I bet you've seen something like this at the doctor's office, but the one that you've seen is probably much bigger. But this scale is, even though it's smaller, it works the same. I'm going to turn it on, and I'm going to put the rocks on the scale to see how much they weigh. So I'm going to put the lighter rock on first, and it weighs 10 grams. So I have a notebook over here, and I'm going to write that data in my notebook, 10.0 grams. Now let's try out one of the heavier rocks and see if the number is bigger. If the number is bigger, that means this rock is definitely heavier. Let's see. 53.4 grams. Is 53 a bigger number than 10? It's much bigger. So that rock is much heavier than the other rock. And now I've recorded my data, and that's what scientists do. So the scale told me some more information about these rocks. Wow, we've done a lot of work today, and we've learned a lot about special super science tools. And these tools, remember, help the scientists turn their senses into super senses. And this week, my challenge for you is for you to think about some different scientific tools that you've seen before. And maybe, if you want to become a scientist, think about what special science tools you would need to do your job. It's a big challenge, but I know you can do it. So have fun, and I'll see you next week, right here on Room 9. Bye!
Teaching in Room 9 is made possible with support of Bank of America, Dana Brown Charitable Trust, Emerson, and viewers like you.